The biggest challenge facing the North American battery supply chain is something that we like to call the lithium conversion gap. The lithium conversion gap is a very simple supply and demand thesis. On the supply side, what we see is a huge supply coming online within the Quebec or James Bay region in Canada. What we put at about 500 million tonnes at plus 1%. With 40 companies currently exploring within James Bay, we see this resource doubling within the next 4 years. So huge supply coming online within the next 4 or 5 years. From a demand perspective, it's very much a similar story. What we have is about 20 to 25 major battery facilities, CAM facilities, battery gigafactories coming online within 2028. What the US Department of Energy slates at about 1,000 gigawatts by 2028. This equates to around 850,000 tonne per annum of lithium chemicals. So huge demand. Currently, if there's any production that's coming out of Canada, it's having to go through to China to be converted, who currently convert about 95% of the world's spodumene. So it's going to have to go all the way through to China and then back to feed into the battery supply chain in North America. So obviously a huge carbon footprint, a logistic cost excursion, but also a matter of national security. What we've seen, both the Canadian and the US government implementing supply chain security measures. Canada has mandated divestment of Chinese companies from critical minerals projects, really forcing a downstream solution to be had. So this, by and large, is the lithium conversion gap. There's no lithium converters currently in the US and Canada, and only about 100,000 tonnes slated for delivery by 2028. So introducing Lithium Universe Limited, committed to closing this lithium conversion gap. So what are the problems? Well, the reality is it's a very complex chemical process, one that's been very difficult to recreate, with existing producers, with delays in ramping up, and issues with the commissioning. Now, that's for us, it boils down to two simple things: proven technology and experienced operators. Now, one of those experienced operators is our chairman, Iggy Tan. Iggy started his time back in 1995, having commissioned the lithium carbonate plant for Greenbushes before moving on to spearhead Galaxy Resources. At Galaxy, he built the first mine to refinery project, including the Mount Cattlin project, rated 140,000 tonne per annum, and the Jiangsu lithium carbonate plant in China at 17,000 tonne per annum. Iggy took Galaxy from what was a $10 million market cap to about $2.5 billion at merger with Orocobre. We've also got on the team Pat Scallon. Pat ran Greenbushes for 25 years. He took that plant from 200,000 tonne per annum to 1.4 million tonne per annum. As we know, Greenbushes is the highest grade and biggest spodumene mine in the world, so it brings a very tested skill set to the group. We've also got Dr. Jingwan Liu. Now, Jingwan is considered to be an international downstream expert, whether that be hydroxide or carbonate. He built the Jiangsu facility with Iggy and has been a specialist technical advisor for over 25 different refineries across Asia, North America, and Europe. This is the 1992 Dream Team, obviously made a name for themselves. So if this is the American Dream Team, I'd like to introduce the Lithium Dream Team. We've obviously got the guys up the top that we've just talked about, but also Terry Stark. Terry is former GM of operations for Galaxy, accountable for the Sal de Vida project in Argentina, the James Bay acquisition in Quebec, and also Mount Cattlin operations. Roger Pova. Roger is the operational specialist, whether it be at Mount Cattlin or Greenbushes. He's run both plants. John Loxton, ex-Hatch Limited. He was the construction manager on site with Jingwan and Iggy when the Jiangsu plant was delivered in China. John Sobleski, the gentleman who's financed both the Mount Cattlin and the Jiangsu lithium carbonate plant. So looking at a little bit more of a macro look, In WA, it's been quite interesting following both of these stories. The Tianqi Kilnana hydroxide plant, plagued with issues, 5 years construction, but 100% over budget, 100% over schedule, and as we believe it, still not up to steady state production. Similarly, Albemarle been all over the Australian Financial Review recently. What we see is, again, 5 years, 18 months of commissioning, and this project is not up to steady state, and they're actually having to parachute Chinese operators in to come fix the plant after it's been built. Now, the same story in North America, particularly in Quebec, so North America Lithium. This operation, they built a lithium carbonate plant now 10 years ago and produced a touch over 100 tonne before being mothballed for the last decade. Same story, Nemaska 1. This project was plagued with schedule, budget and major design flaws. So issues, again, reiterating the issues of taking this technology outside China. So what are the real problems with what's been done with these projects? For us, it boils down to these things. So it's a lack of real operational direction at design, lack of commissioning and maintenance experience embedded within the design stage of the project. So that's why we built a team of lithium operators. The proven track record speaks for itself. The Jiangsu project itself, it was a 25-month ordeal, just including 6 months of wet commissioning. So a very on-time project, on budget. This project itself, it's a Western style plant, so it's built to international and Australian standards. This project is semi-autonomous, fully continuous, and it actually became the benchmark for process technology and process control in China. To show you how early on this was built, it actually doubled the whole conversion capacity of China when this was commissioned. Recent trip to China, we saw a lot of the same technology sprinkled across all the refineries that we visited. So our model is very simple. We're building the Becancour Lithium Refinery, 16,000 tonne per annum battery grade lithium carbonate plant. It's based on the very proven Jiangsu design, winterized for the Quebec environment. And this project, it's based on the Jiangsu design. We've got the same flow sheet, same equipment, and same suppliers, removing technical risk. And what we've looked to do here is make the design as robust as possible so we can treat any types of spodumene from around the world. We partnered with Hatch, who likely don't need an introduction. This company, Hatch, were on board when Jiangsu was delivered for Galaxy. We've obviously got John Loxton on board to manage Hatch. Hatch, we've got a very strong track record there, and they're going to bring it up to provincial standard, winterize it for the Quebec environment. Now, why carbonate versus hydroxide? A very common question. As we know, lithium carbonate is the precursor element for lithium iron phosphate batteries, or LFP batteries. What we've seen last year, LFP batteries demanded 70% of all EV installations in China. And over the next decade, fast markets predict that they're going to have just short of 90% of all energy storage systems. So there's a strong demand. So strong that a lot of the refineries that we saw in China just recently are strategizing to either build lithium carbonate legs or expand completely new operations into lithium carbonate to meet this demand. So Becancour's in between Montreal and Quebec City. We're at the Becancour Industrial Hub, which has become known as the Battery Valley. Becancour itself, it's got all the utilities, natural gas, water, industrial wastewater facilities. We're right next to the highway. We've got railway access, but most importantly, we've got a port facility. We've got the capacity to not only put one train or one refinery, but 3 refineries for a potential total capacity of 48,000 tonne per annum. Now, why port is very important, because as we wait for the James Bay region to come online, we have the ability to bring in spodumene via the Atlantic through the St. Lawrence into the Becancour port. This further reinstates the need for us to have a robust flow sheet so we can process any type of spodumene. This is the flow sheet. We've published it to market. It's the conventional design. It's the Jiangsu design. We've got the bicarb purifier circuit at the back end to make sure and ensure that we've got the battery grade spec. Now, in order to winterize it, we've obviously had to change the layout. This is the layout here. What you can see here, we go through the conventional process of calcination. So typically what you see is the big kiln, typically 1.8 to 2 metres in diameter, 50 to 60 metres long. Before going on to the sulfation circuit, through impurity removal, before precipitating the lithium carbonate. Byproduct is sodium sulfate, saleable through the textile and detergent industry in China and an emerging industry in North America. So what we've done is we've sourced samples from Australia, from Brazil, from Canada and Africa, some of the most impurity-rich spodumene that we could find, and we've put it through the process to ensure to ourselves and to stakeholders and potential partners that we can process any type of spodumene. And all of the results have come back to date at greater than 99.5% or battery grade at 99.7%. So the flow sheet is validated. So the next step for us is really looking at how we're going to implement this into the market. Now the OEMs have offtake or looking to find offtake, so your Ford, your Tesla, your LG, but currently they're having to send it through to China to be converted before going back into the supply chain in North America. As I said, this is a carbon footprint issue, a cost implication, also a security risk to the supply chain. So for us, it's a very simple take or pay conversion model, one that we think will pay back the refinery within the next 3 to 4 years after it's built. So we're essentially becoming part of the OEM supply chain. The reason why we can make this happen is the reality around the hydroelectricity within Becancour and Quebec itself. At 2.6 cents a kilowatt, it's the reason why operational expenses can compete or go close to competing with the Chinese operational expenses. What you see in China typically between 12 and 15 cents a kilowatt. Now, what we've done on site, we've obviously got the option on the ground. Application to Hydro-Quebec's gone in, and in talking to the Minister of Economics and Energy, we see that there's no real issues in that energy block allocation. We've completed some environmental surveys, flora and fauna, and no foreseeable issues based on the initial work that we've done. We've engaged with the Wabanaki, which are the local First Nation group, who obviously work with a lot of our other peers in the Becancour Industrial Hub, and they're a strong supporter of what we're doing. So, by and large, ladies and gentlemen, this is the Lithium Universe. We've got the Lithium Dream Team with a proven track record of delivering projects like this before. We've got the proven technology in a tried and tested process that has been delivering battery grade spec in China for the last 10 years. And finally, where we've placed ourselves is in Becancour, not only in access to the hydroelectricity, but obviously on the doorstep of the growing James Bay region. So ladies and gentlemen, thanks for listening, and I hope to welcome you on our journey to the universe.